Hello friends, now we'll start the new chapter, integrals. In this video, I will explain the integration is the inverse process of differentiation, all formulas, standard formulas, and all solved examples before exercise 7.1. This is the first part of exercise 7.1, and in my second video, I will solve all the examples from the exercise 7.1. I will give the link of that second video in the description box as well as in the comment section. Now let us start. Integration is the inverse process of differentiation. Instead of differentiating a function, we are given the derivative of the function and asked to find its primitive. Means what? The original function. Means what? The integral of that function. Okay. Such a process is called integration or anti-differentiation. Now we'll see some examples. Let us consider the following examples. First example, we know that the ddx of sin x is equals to cos x. And suppose that we want to find out the integral of the cos of x, then we will ask the question, which is the function whose derivative is the cos of x? That is nothing but the sin x. And therefore, the integral of cos of x is a sin x. See this here. We observe that in the function cos of x is the derivative of sin x. Therefore, we say that sin of x is an antiderivative of cos of x. Means integral of cos of x is the sin x. Okay, in this way. Now the next example, ddx of x cube upon 3 is equals to x square. And suppose that if we want to find out the integral of x square, then I will ask the question, which is the function whose derivative is the x square? Then x cube upon 3 is the function whose derivative is the x square, and that's why the integral of x square is x cube upon 3. Okay, that is again, you see this here. We observe that in the function x square is the derived from x cube upon 3, and therefore the integral of x square is x cube upon 3. Okay, therefore we say that the x cube upon 3 is the antiderivative or the integral of x square. Means we must know the derivative of the function, then we can find out the integral of function directly. Okay. Now the next example, similarly here, the derivative of e raised to x is e raised to x, and hence the integral of e raised to x is e raised to x. Then again I will ask the question, which is the function whose derivative is e raised to x? And that is nothing but the e raised to x. And therefore, e raised to x is again the antiderivative of e raised to x in this way. Now, again, we note that for any real number c treated as a constant function, its a derivative is 0, and hence we can write 1, 2, and 3 as follows. ddx of sin x plus c, that's cos x. There will be 5, 6, and this type of the numbers. ddx of x cube upon 3 plus c, that is also x square. ddx of e raised to x plus c, that is also e raised to x. You can take c as an arbitrary constant. Thus, antiderivatives or integrals of the above cited functions are not unique. Okay, their integrals are not unique. It depends upon the value of this arbitrary constant. Okay, therefore, there exist infinitely many antiderivatives of each of these functions, which can be obtained by choosing C arbitrarily from the set of real numbers. Okay. For this reason, C is customarily referred to as an arbitrary constant. In fact, C is the parameter by varying which one gets different antiderivatives or the integrals of the function. Okay. We now introduce a new symbol, namely this symbol, that is the integral f of x dx, which will represent the entire class of antiderivatives and read as indefinite integral of f. This we can read as indefinite integral of f with respect to x. And symbolically, we write integral of f of x into dx is equals to capital F of x plus c. Okay. Notation given that dy by dx is equals to f of x, we write y is equals to integral of f of x in this way. We take integral on both sides, and here you will get y is equals to integral of f of x into dx. Okay. Now in this table, there are symbols and their meaning. Okay. The first is integral of f of x into dx. It can be read as, that is the integral of f with respect to x. F of x in integral of f of x dx, that is it's a integrand. X in integral of f of x dx, that is nothing but the variable of integration. Integrate, find the integral. An integral of f, a function capital F, such that here f dash of x is equals to small f of x. Integration, the process of finding the integral. Constant of integration for any real number c considered as constant functions. These are the symbols and their meanings we will use when we solve the examples. Okay. We already know the formulae for the derivatives of many important functions. From these formulae, we can write down immediately the corresponding formulae for the integrals of these functions as listed below, which will be used to find integrals of others function. Means what? If we know the derivative of function, we can find out directly it's an integral. Now the list is given here below. See the first. Here the derivatives in this column and the integrals, that is the antiderivatives. The first is ddx of x raised to n plus 1 upon n plus 1, that is equals to x raised to n. Then it's clear that the integral of x raised to n into dx is equals to x raised to n plus 1 upon n plus 1. See this here. The integral of x raised to n into dx is equals to x raised to n plus 1 upon n plus 1 plus c, where the value of n is not equals to minus 1. Okay. And when it is a minus 1, that I will explain when we find out the integral of 1 upon x into dx. Okay. But here you remember this. The integral of x raised to n into dx is equals to x raised to n plus 1 upon n plus 1. For example, suppose that you want to find out the integral of x square into dx. Then what's its integral? That is a x raised to 2 plus 1 upon 2 plus 1 plus c. Means what? Its integral is a x cube upon 3 plus c. That is, whatever this number here you add 1 and divide with that number, then you will get the integral of that function. Again, the next example, if there is any fraction, okay, it is here integral of x raised to minus 5 by 2 into dx. Then what's its integral? Its integral is a x raised to minus 5 by 2 plus 1 upon minus 5 by 2 plus 1 plus c. And if we evaluate it, then what you will get, that is a x raised to minus, here is a 3 by 2 x raised to minus 3 by 2 and upon here 3 by 2 plus c. It means that if you want to find out the integral, add the number 1 and divide that addition here, then you will get the integral of that function. Now the next, here the derivative of x is 1 and therefore the integral of 1 into dx, that is nothing but the x. Here again one more thing is that, suppose you want to find out the integral of 5 dx, then what will be its integral? Its integral is a 5x plus c. Integral of minus 7 by 2 into dx, its integral is a minus 7 by 2 x plus c, and in this way you can find out. Okay. Now the next example. Next formula here. ddx of sin x is a cos x. Then I will ask the question, which is the function whose derivative is a cos x? Okay. And that is nothing but the sin x, and hence the integral of cos x is the sin x. This is next. ddx of again minus cos x is a sin x, and therefore the integral of sin x is a minus cos x. ddx of tan x is x square. Then suppose that I want to find out the integral of sec square. Then I will ask the question, which is the function whose derivative is a sec square? That is nothing but the tan x, and hence the integral of sec square x into dx is equals to tan x. Next, if I want to find out the integral of cosec square, then I will ask the question, which is the function whose derivative is a cosec square x? Then the answer is a minus cot x, and hence the integral of cosec square x into dx is nothing but minus cot x. Okay. Next, suppose that I want to find out the integral of sec x into tan x. Again I will ask the question, which is the function whose derivative is a sec x into tan x? Then there is answer. The derivative of sec x is a sec x into tan x, and hence the integral of sec x into tan x is a sec x. Next, suppose that I want to find out the integral of cosec x into cot x. Then again I will ask the question, which is the function whose derivative is a cosec x into cot x? That is nothing but the minus cosec x, and hence the integral of cosec x into cot x is a minus cosec x. Next, integral of sec square x. Again, which is the function whose derivative is a sec square x? Then the answer is a tan x. The derivative of tan x is a sec square x, and hence the integral of sec square is a tan x. Again, suppose that I want to find out the integral of cosec square x. Then again the question, which is the function whose derivative is a cosec square x? Here is it's a derivative cosec square x. Then the derivative of minus cot x is the cosec square x, and hence the integral of cosec square is nothing but the minus cot x. And again next, suppose I want to find out the integral of sec x into tan x. Then again I will ask the question, which is the function whose derivative is a sec x into tan x? That is nothing but the sec x, and hence integral of sec x into tan x is the sec x. Okay, next question, integral, that is the integral of cosec x into cortex. Then again I will ask the question, which is the function whose derivative is a sec x into cortex? That is the derivative of, which is the function whose derivative is a cosec x into cortex. Okay, that is the derivative of minus cosec x is cosec x into cortex, and hence the integral of cosec x into cortex is a minus cosec x. The same thing is also here. Again, suppose that I want to find out the integral of 1 upon in under root of 1 minus x square. Then again I will ask the question, which is the function whose derivative is 1 upon in root of 1 minus x square, and that's nothing but the sine inverse of x, and hence the integral of 1 upon in under root of 1 minus x square into dx is the sine inverse of x. Again the integral of 1 upon in root of 1 minus x square. Then again I will ask the question, which is the function whose integral is 1 upon in root of 1, whose derivative is 1 upon in root of 1 minus x square, and that's nothing but the minus cosec inverse of x, and hence integral of dx upon in root of 1 minus x square, that is equals to minus cos inverse of x plus c. Okay. Next, suppose that I want to find out the integral of 1 upon 1 plus x square. Then again I will ask the question, which is the function whose derivative is 1 upon 1 plus x square, and that is nothing but the tan inverse of x, and hence the integral of 1 upon 1 plus x square, its integral is a tan inverse of x. Next, suppose that again I want to find out the integral of 1 upon 1 plus x square into dx. Then again I will ask the question, which is the function whose derivative is 1 upon 1 plus x square, and that's nothing but the minus cot inverse of x, and therefore the integral of dx upon 1 plus x square, that's equals to minus cot inverse of x. Next, suppose that I want to find out the integral of 1 upon x in root of x square minus 1. Okay, then again I will ask the question, which is the function whose derivative is 1 upon x into in root of 1 in root of x square minus 1, and that function is nothing but sec inverse of x, and hence integral of dx upon x in root of x square minus 1 is nothing but the sec inverse of x. Again next integral dx upon x into in root of x square minus 1. Again I will ask the question, which is the function whose derivative is 1 upon x into in root of x square minus 1. That is nothing but the minus cosec inverse of x, and hence the integral of dx upon x in root of x square minus 1 is nothing but the minus cosec inverse of x. Again this is very simple integral, that is integral of e raised to x. Again I will ask the question, which is the function whose derivative is e raised to x? The derivative of the e raised to x is the e raised to x, and hence its integral is a e raised to x. Now see this here. Again, which is the function whose derivative is 1 upon x? Okay, yes, there is a function, that is a log of mod of x, whose derivative is 1 upon x, and hence the integral of 1 upon x is the log of mod of x plus c. Again, there is a next formula, integral of a raised to x into dx. Then I will ask again the question, which is the function whose derivative is a raised to x, and that's nothing but a raised to x upon log of a. That's the derivative of a raised to x upon log of a is a raised to x, and hence the integral of a raised to x is a raised to x upon log of a plus c. And in this way you can remember all these integrals with the help of the derivatives. Okay, now Here, the first we start the solved example. Write an antiderivative or the integral for each of the following functions using method of inspection. Okay, here I want to find out the integral of cos of 2x. This is with the help of the inspection. Now again I will ask the question, which is the function whose derivative is the cos of 2x? See this here, cos of 2x into 1 upon 2 ddx of sine of 2x. We can take this 1 upon 2 in this bracket. That is the ddx of 1 upon 2 into sine 2x. Its a derivative is a cos 2x, and hence the integral of cos of 2x is nothing but 1 upon 2 sine 2x. Okay. Next example, 3x square plus 4x cube. Again I will ask the question, which is the function whose derivative is 3x square plus 4x cube? Now we have the function that is the ddx of x cube plus x raised to 4. Its a derivative is a 3x square plus 4x cube, and hence the integral of 3x square plus 4x cube, which is nothing but our example. Its integral is a x cube plus x raised to 4. Okay, this is with the help of the inspection. Next, 1 upon x, where x is not equals to 0. Again, this is very important. We know that again I will ask the question, which is the function whose derivative is 1 upon x, log of x. Okay, ddx of log of x is 1 upon x for x is greater than 0, and ddx of log of minus x, that is equals to 1 upon minus x into ddx of minus x minus 1, and overall it becomes plus where x is a negative. And combining these two, we take here mod, and therefore ddx of log of mod of x, that's equals to 1 upon x. It means that the derivative of log of mod of x is 1 upon x. We want to find out the integral of 1 upon x, and hence the integral of 1 upon x into dx is nothing but the log of mod of x. Okay, now the next examples. These are the examples we solved this by the direct method of the integration. Now the first example, integral x cube minus 1 upon x square. Now to find out the integral of this, see this here, x cube minus 1 upon x square, we will split up it like this, x cube upon x square minus 1 upon x square, okay, into dx. Now again by the law of indices, x raised to 3 upon x square, and that's nothing but the x, and again 1 upon x square means what, its exponent will become minus into dx. And now you can find out the integral of x. Its power is 1, therefore 1 plus 1 upon 1 plus 1 plus c1, it's a constant of integration for this. And for the next, x raised to minus 2, again plus 1, minus 2 plus 1 upon minus 2 plus 1 plus c2, which is the formula here, the integral of x raised to n into dx is equals to x raised to n plus 1 upon n plus 1 plus c. Okay, and in this way we get where c1 and c2 are the constant of integration. Now collect this term, that is x raised to minus 2 plus 1, it's x raised to minus 1 upon minus 1, this minus that will become plus x square upon 2. As its power is minus 1, we can take by using the law of indices 1 upon x plus c1 minus c2, and overall there is a unique constant which is c1 minus c2, that's again nothing but the constant c, and hence the integral of x cube minus 1 upon x square into dx, that's equals to x square upon 2 plus 1 upon x plus c. Okay, this is the answer. Now, next problem. Integral of x raised to 2 by 3 plus 1 dx. Now again just split up it. Again by using the formula x raised to n into dx, that's equals to x raised to n plus 1 upon n plus 1 plus 3, whatever this index, that is at 2 raised to 3 by 2 plus 1 upon 2 by 3 plus 1. Okay, and integral of this constant 1 dx, that is nothing but the x and plus c. 2 raised to 2 by 3 plus 1, that is a 3 into 1 3, 3 plus 2 5, that is x raised to 5 by 2 upon 5 by 2, and multiplied and reciprocal, it will become 3 by 2 into x raised to 5 by 2 plus x plus c, and hence the answer integral of x raised to 2 by 3 plus 1 into dx is equals to 3 by 5 into x raised to 5 by 3 plus x plus c. Okay, now the answer. Next problem. Integral of x raised to 3 by 2 plus 2 into e raised to x minus 1 upon x dx. Now separate this. Integral of x raised to 3 by 2 into dx. As the 2 is a constant, so keep it as it is. 2 into e raised to x into dx minus integral of 1 upon x. Now again, integral of x raised to 3 by 2 means what? X raised to 3 by 2 plus 1 upon 3 by 2 plus 1. Integral of e raised to x, we know that the integral of e raised to x is a e raised to x, and the integral of 1 upon x, that is the log of mod of x plus c. Now simplify this. X raised to 3 by 2 plus 1 is nothing but the x raised to 5 by 2 upon 5 by 2, and multiplied and reciprocal, it will become 2 by 5 into x raised to 5 by 2 plus 2 e raised to x minus log of mod of x plus c. Okay, and this is the answer. Okay. Now the next problem. Find the following integrals. Integral of sin x plus cos x. Now first integral of in bracket sin x plus cos x into dx. Separate it. Find out the integral of sin x into dx plus integral of cos of x into dx. Integral of sin of x is the minus cos x. Integral of cos of x is the sin x, and the c is a constant of integration. Okay. This is the answer. Okay. Now the next problem. Integral of cosec x in bracket cosec x plus cortex into dx. Again, now to find out the integral of this, we will simplify this. It's like this. What is that? Integral cosec x in bracket cosec x plus cortex. We will simplify this because we don't know the directly integral of this expression. Therefore, there is a multiplication cosec x into cosec x. Here you will get cosec square x plus cosec x into cortex. Cosec x into cortex, bracket complete into dx. Okay. Now the integral of the cosec square x into dx into integral of the cosec x into cortex. Again, we know which is the function whose derivative is the cosec square x, which is the minus cortex. Again, which is the function whose derivative is the cosec x into cortex, that is the minus cosec x. Also, you can remember the integral of cosec square x is a minus cortex, and integral of cosec x into cortex is a minus cosec x. Okay, and this is the answer. Next, integral of 1 minus sin x upon cos square x into dx. Now separate this. That is 1 upon cos square x into dx minus sin x upon cos square x. Now this can be written as, that is a sin x upon this cos square means what? 1 upon is cos x into 1 upon cos x. Now sin x upon cos x means what? It becomes tan x, and 1 upon cos x, it becomes sec x. Again, the integral of sec square is a tan x, and the integral of tan x into sec x is a sec x, and therefore the integral of 1 minus sin x upon cos square x into dx, That's equals to tan x minus sec x plus c. Okay. Therefore, this is the answer. Now the next is the next problem. Example number 4. Find the antiderivative capital F of f defined by f of x is equals to 4x cube minus 6, where f of 0 is 3. Hence we want to find out the integral of 4x cube minus 6. Okay. And here we have given the value of that capital function. So value at x is equals to 0 is 3. Okay. Now here that is a 1, that is the antiderivative of f of x is a x square x raised to 4 minus 6x, since ddx of x raised to 4 minus 6x is equals to 4x cube minus 6, and hence the integral of 4x cube minus 6 is x raised to 4 minus 6x plus 3. Okay. Again we will ask the question, which is the function whose derivative is a 4x cube minus 6, and that function is nothing but x raised to 4 minus 6x plus c, and therefore we have the function f of x. This we want to find out. Now its value when x is equals to 0, if we substitute x is equals to 0, then what will happen? F of 0, that is equals to 3, f of 0 is 3, x is replaced by 0, minus 6 into 0 plus c, and overall you will get here c is equals to 3. Substitute the value of that c3 here, and hence you will get the function f of x is equals to x raised to 4 minus 6x plus 3. Okay. Now we'll start the exercise 7.1, and now this will be in my second video. I will give the link of my second video in the description box as well as in the comment section. Now we'll see in the next video in which I will explain all examples of exercise 7.1.